Hello Year 5, hopefully you found the video about equivalent fractions helpful and that you're able to have a go at that question, but here are your answers for today. So we're looking at an addition problem, and when you look at it, I suppose the problem that we're looking at here, or the challenge we're trying to overcome, is that we've got 5 numbers to add together. So the more numbers we're adding together, the more chance there is of us not working very accurately. So I'm going to show you the way that I would do it and then offer some alternative suggestions that could be even more accurate for you if you're not feeling so confident. So I'm just going to use column addition, and I know that my mental maths is pretty good. So the chances of me making a mistake if I'm careful are quite low. That doesn't mean it's not impossible. Okay, so I'm again always making sure that my numbers match. I've got 5 numbers, that's a good start because there's 5 numbers to add together in the question. 159, 109, 98, 74 and 58, and my numbers match. I have ordered them with the biggest at the top, which is always a good strategy to use that we've talked about in school. So now I'm looking for pairs of numbers that I can add together really well. So when I look at these, excuse me, it's not a very good start, is it? When I look at these numbers, actually what jumps out to me, I'm going to have a glass of water. This is not the code, by the way, to send me coughs. Okay, the code word I was on about there is not cough. All right, so what jumps out to me is that 8 and 8 is 16. And 16 add 4 is 20, but that's because I know my number facts really clearly. I would have thought for most of you that wouldn't jump out. So you'd be looking at numbers that add together easily, like doubling 9 or doubling 8. So I know that those 3 numbers add together to make 20, and then 9 and 9 is 18. So 20 add 18, or 20 add 10 is 30, and then another 8, so it's 38. Okay, and like I said, in a minute I will give you a different strategy to use if this is a bit tricky. So again, I'm looking and I've got 5, I'm going to put a dot there, 5 and 5, so I'm not missing it. 5 and 5 is 10, 10 and 9 is 19. Okay, 9 add 1 is 20, so I've got 6 left, so that's 26, and then 26 add 3 is 9, 29, and then we're looking here. Crossing that off to remind me I've done it. 1 add 1 is 2, add another 2 is 498. Now, if you found that too tricky to do, what I would have done is maybe done a sum, a different sort of strategy, is maybe do a sum and add 2 or 3 of the numbers together, and then you want to just group them by here. So add these two, oh, that's terrible. Add them in 2 groups together and then add your totals together, because the less numbers you're adding together, the less chance there is of making a mistake. So you could add those 3 together and then the bigger 2 is up to you, but that would be what I would do if you looked at that and thought, oh my goodness, I can't keep these numbers in my head. Okay, right, subtractions. We've got 15 subtract 2.98. So my first way of showing you is doing what probably you all have gone for, is column subtraction. Hopefully not everybody has, but I would have thought it'd be the first thing you'd think about doing. Now, what I've made sure is when I've set my sum up is that my numbers line up. In 15, the units or the ones is the 5, must line up with the 2. Okay, I wouldn't put my 15 over here because then I'd be in the decimals, and 15 is a whole number. So what I need to do is to make this number longer, okay, so that I can start thinking about exchanging and so on. But I'm not making it worth anymore. I'm not making it a bigger number. It's still just 15. So I now need to think about 0, take away 8. I can't do that. So I need to exchange all the way from over here. Okay. And then remember, you can only exchange between columns next to each other. Doesn't help me, so I need to exchange again. Okay, and I'm going to exchange 1/10, so in that column. And then I've got 10 hundredths. So I'm going to take away 8 hundredths. So I'm left with 2. Okay, 9 subtract 9 is 0, and then I'm going to put my decimal point in. You can do that at the beginning if you want to. 4 subtract 2 is 2, and then we've got 1 there. So the answer is 12.02. So that wasn't too difficult. So it was just showing you or reminding you of the fact that if you're subtracting a number that's got more decimal places than the number you're starting with, you can make that first number, that top number here, longer by adding a 0 after the decimal point, or a few zeros if you need to. So you're not making it any bigger, so you're not changing the sum or the calculation you're doing. In my head, this is what I would be doing. I would probably make some notes because the numbers are a little bit further away. I may not have to. Okay, so I'm thinking about using addition rather than subtraction and using my understanding of place value. So I'm thinking I've got 2.98 So I've got 98 hundredths here. My next whole number is 3, so I'm almost at 3, and I need to add 2 hundredths to that. So it'd be 0.02, which is a bit annoying, so let's go back. I cannot wait to be back at school where I can just write for you, and hopefully it will be clear, fingers crossed. Okay, 0.02, because that 2 there is in the hundredths column. If I put 0.2, I'd be adding 20 hundredths or 2 tenths. So that would take me to 3.18. We're trying to get to 3 here. And then 3 up to 10 is a jump of 7, and then 5. So then all I have to do is add my jumps together. 5 add 5 is 10, so 7 is 2 more, so it's 12. 12.02, we get the same answer. Okay, so there's 2 different ways of doing it, and hopefully you are confident with both. Right, still looking at long multiplication. I will have worked with some of you on this last week, so hopefully everybody's feeling much more confident with this. Okay, so this is how I'd set it out. I don't expect you to write this, but I'm showing you on this line, my answer is going to be the answer to 5 multiplied by our number. And then this line is the answer to 30 multiplied it, and then we add those 2 together and we'll have 35 times it. Okay, so the first line everybody's confident with, and it's our 5 times table, so we're fine with that. So 5 multiplied by 7 is 35. Okay, and then 5 multiplied by 0, again try to catch you out. If you've got nothing, 5 lots of nothing is still nothing, so we're just going to have our 3. I'm going to cross off that 3 there to make sure that I don't add it up at the end. And then 5 multiplied by 4 is 20. Okay, so if my sum was 5 multiplied by 407, that would be my answer. But now I'm going to multiply by the tens column. And what I'm going to show you is why, and I've probably shown you this before, or if I work with you in a group, why we have to add the 0 in to show that we've moved each of the digits up. So if I show you now, change colour. So if I thought about this as just 3 times 7, okay, it's 21. Now there was a challenge last week which is all about times tables that you're not sure of and a way of working them out, which was to make some jottings down here. So I would be thinking about, I know 5 times 3 is 15, and I know 2 times 3 is 6. I'd have to add them together. So please don't give up on this because it's your 3 times table or your 7s. Okay, 3 times 0 is 3, and I've put that 2 there, and 3 times 4 is 12. Okay, so I'm lining my numbers up really carefully. Okay, so that is the answer to 3 times 407. I want to do 30 times 407. Okay, so what I'm going to have to do, and hopefully this will work and you can see it, is I'm going to have to move my digits up 1 column because I'm going to make them worth 10 times more than they were. And then I'm going to put my 0 in. Now, you do not work on a computer like this, so for you to move the digits, you have to do lots of rubbings out, or you'd have to start again. So that's why we put that 0, that placeholder in there, to show that we are multiplying by the tens column. So we can think about it as 3 times each of these numbers, but we're actually doing 30 times it, which means we're going to move everything up 1 column. We've got to put that placeholder there. So that's why we put the 0 in first, so it doesn't become confusing. And then all you've got to do is to add it together. So 5 times 5 add 0 is 5, 3 add 1 is 4, 2 and 4 and 1. So my answer is 14,245. If I ended up with a number that was smaller than my biggest number, I know I haven't added it up correctly. So make sure when you're looking at it, like have a bit of an estimate first. So 12,000 add 2,000, my answer needed to be around 14,000. So if it was 48,000, I know I would have made a mistake. Okay, so now looking at equivalent fractions. Now if you didn't look at this video this morning, I would advise you to stop this video and go back and watch the short one that I posted on your portfolio, because it will give you a bit more of an explanation with some diagrams and things like that. But we were looking at equivalent fractions, and equivalent meaning equal to or worth the same amount. Okay, and we were thinking about, first of all, I did some rectangles and showed you that they must take up, when we were looking at halves, and they must take up the same amount of space, so they must be worth the same. What we started to look at then was the relationship between the numbers, because whatever happens to the bottom number here, we've got to do the same to the top number, and that will guarantee that our fraction is an equivalent fraction. So whatever you do to the denominator, you must do to the numerator. So what have I done to 4 to get it to 8? Well, I've doubled it, okay? So I've made it twice as big, so I need to make this number twice as big. So 1 times 2 is 2. So a quarter and 2/8 are equivalent fractions of each other. They're worth the same amount. Okay, so now I'm going to think about, okay, what do I do to 4 to get it to 12? So if we count in 4s, you go 4, 8, 12, so I've times it by 3. Okay, so I've got to do, in order to keep my fraction equivalent, I've got to do the same here. So I've got to do 1 times 3. So 3/12 is an equivalent fraction for a quarter. Okay, and then the last one we'll do is think about, what do I do to 4 to get it to 16? So if I times it by 3, I get to 12. It's one more lot, so I've got to times it by 4. We'll make it 4 times bigger. So I've got to do the same to my numerator. And each time I'm going back to the original fraction, okay? Because that's much easier. It's a number that is, the numbers are much more familiar, okay? So they are your answers. So all 4 of those fractions are equivalent fractions, or those 3 fractions, sorry, equivalent fractions to a quarter. As I said, I would go back and watch that video this morning because I had some diagrams and I explained it in much more detail. But hopefully you found it okay. Right, moving over to the other side of the board. So 1 and 1/5, add what gives us 3. Okay, so 3 wholes. So we've got 1 whole and then part of a fraction. We're going to add something to it. Okay, so I have drawn something as usual. Now, I haven't split this into 5 because in a minute we'll see that we don't need it. However, in your jotter you've got squares, so they're much easier to use. So I'm thinking about, I could have shaded in this one and then one part here, but actually I've shaded in this instead. So it doesn't really matter what you colour in so long as you colour in the right amount. So 1 whole and 1/5. I haven't coloured it beautifully. I haven't coloured in the whole sort of part of each equal part. I haven't coloured it in sort of all there. But what I have done is I've done 1 whole and 1/5. So now what I'm going to look at is, what do I have left? Because whatever I've got left is what I've got to add to it to give me the 3 wholes. So I've got 1 whole. So my answer is going to be 1 whole. And then I've got 1, 2, 3, 4 equal parts. Okay, that's what I need to add to it. Out of 5, which it takes 5 equal parts to have a whole. So your answer is 1 whole and 4/5. You may have worked out that another way of saying that would be 9/5. So if you've got either of those answers, it would be correct, because this is 1 whole is 5 out of 5. So what you might have done is counted up all of the equal parts. So 5, 6, 7, 8, 9. Either of those answers is correct. This would be the one that would show a bit of a better understanding, but that one would give you the correct answer as well. Okay, right, thinking about just practicing exchanging, really, I think it's really important that we keep these sort of skills sharp. So 8 subtract 6, okay, is a difference of 2. 9 subtract 5 is a difference of 4. 1 subtract 7, we can't do. I can't exchange from this column, so I'm going to have to move up to the next one. And I'm going to remind myself that I can only exchange between columns next to each other. So go back to here, I still can't do it. Okay, so instead of having 10 lots of the thousands there, I've got 9. And I'm going to bring it over to the hundreds column. Okay, so 11 subtract 7. Well, 7 add 3 is 10, so it's 1 more, so it's 4 again. 9 subtract 5 is 4 again. And 4 subtract 4 is 0. I don't have to put that 0 in. If you put it in, the answer is exactly the same. It's still 4,442. Okay, right. Again, we're thinking about using what we know to help us with what we don't know. So I'm looking at these numbers and I'm going to say I'm going to start with 9 multiplied by 2, which is 18. Okay, you all know your 2 times table, so don't be put off by that. So the number now, instead of 9 has become 90, it's 10 times bigger, so my answer is going to be 10 times bigger. So it's 180. Then 90 stays as it is, okay, but the 2 has now become 20, so that's 10 times bigger. So my answer needs to be 10 times bigger again. Okay, and what I would be doing is moving each of the digits up, okay, and then filling the gaps that have been left with zeros. Okay, so the final answer would be 18, thousand. That is a very big comma, but that's all it is. It's not a 1. So the answer is 18,000. Right, finally, we've got our word problem. And I know Mrs. Townsend will be Mrs. Townsend will be interested to see how you got on with this, because this was the unit that she's been teaching you on a Tuesday. Now, in order to get your 10 dojo points, I want you to look back at your question paper. Okay, so the one that you filled in that has got Monday on with all the questions with your answers. And you need to send me the word that has been spelt incorrectly. Okay, so look at what I've written on that page. There is a word that's been spelt incorrectly. You need to look back at your page, not at this page. So I'm going to underline. So it's a rectangle. Okay. It's got sides measuring 8 and 5 centimetres, and I'm trying to find the perimeter. That's what I'm going to start off with first. So I have underlined and drawn something to make it clear. I've got to remind myself what is perimeter. I can sometimes get these mixed up, but I can remember perimeter is adding together all the sides. Now, just because I haven't labelled them all, I know that this is 8 and this is 5 as well, because that's all to do with my understanding of rectangles and the properties of them. So they have 2 sides the same length and 2 other sides the same length. Okay, so for perimeter I just need to add them together. So 8 and 8 is 16, 5 and 5 is 10. So the answer would be 26 centimetres. Okay, so that is the answer you are looking for. Okay, so then the challenge, if one of the sides becomes 1 centimetre longer, okay, what 2 measurements could be the rectangle's area? So I need to remind myself that area is when you multiply. So I've got to look. So if one of these numbers becomes 1 centimetre longer, so I'm going to start with this one and make that 9. So I've got to multiply. 9 times 5 is 45. Now, perimeter is measured in centimetres or metres or kilometres, but area is centimetres or metres or kilometres squared. So that would be my answer. But it says what 2 measurements. I need to go back to the question and say if one of the sides, okay, so instead of the 8 changing, I'm going to now make the 5 a 6. Okay, so 8 times 6. Now I know 8 times 5 is 40 because I know my 5 times table. So 8 times 6 would be another lot of 8. So it would be 48 centimetres squared. So they are the 2 measurements that you could have as your area if one of the sides increase its length by a centimetre. So they're the 2 answers you're looking for. Okay, let me know how you've got on and have a good day.